it would explode and destroy all of New York City, parts of Connecticut and New Jersey. This is one of the greatest mysteries in our physics.
In the constellation Orion, there's a star that's fascinated astronomers for ages. Betelgeuse, a red supergiant, outshines our Sun by leaps and bounds in size and mass. However, recently, it's been behaving oddly. It's dimmed significantly and started vibrating violently. This has sparked talk that this once lively star might be about to go supernova. But what if there's something even scarier happening? What if Betelgeuse isn't gearing up to explode, but rather to collapse in on itself? Let's delve into the latest research on Betelgeuse and what it could mean for us. We're on a quest to understand the potential consequences of Betelgeuse's collapse for the future of our universe. Betelgeuse is a massive star, dwarfing our Sun by a whopping 950 times, making it one of the largest in the universe. But its immense size comes with a catch. Stars like Betelgeuse have finite lifespans, and this one is no exception. It's like a ticking time bomb, ready to go off. But we're still uncertain about when exactly. Located just 650 light-years away, Betelgeuse has mesmerized astronomers, shining as one of our closest celestial neighbors. We're captivated by its brilliance, trying to unlock the mysteries hidden within its fiery core. Even though only 133% of its radiant energy is visible to us, if we could see its full splendor, it would outshine even Sirius, reigning as the brightest star in our night sky. Picture a mammoth star so colossal that its radius dwarfs our Sun's by 764 times, stretching far beyond the asteroid belt, almost reaching out to touch Jupiter. Within this expansive domain, Earth, Mars, Mercury and Venus would be engulfed by Betelgeuse's irresistible cosmic pull. But the enigma doesn't stop there. Every 1,000 years, Betelgeuse sheds a solar mass, shedding its stellar remnants in a breathtaking cosmic spectacle. A nebula, an astounding 250 times larger than the star itself, envelops Betelgeuse, wrapping it in a mystical haze that mesmerizes our gaze. This nebula, extending 30 astronomical units, invites us into a cosmic waltz of fascination, enticing us to unveil its secrets. Let's delve deeper into the genesis of Betelgeuse, where the alchemy of hydrogen fusion sparks, giving birth to helium in a cosmic burst. As time progresses, the star's hydrogen fuel diminishes, prompting a celestial metamorphosis. Helium merges with carbon, unleashing a brilliance that ripples through the universe.
But even this magnificent fusion has its boundaries. When neon collides with iron, a remarkable transformation takes place. The star's gravity, unshackled by the absence of energy release, triggers an impending collapse, hurtling Betelgeuse toward a destiny both breathtaking and catastrophic, a supernova explosion. In the realm of cosmic wonders, supernovae reign supreme, and Betelgeuse is no exception. With the energy equivalent of 10 billion suns, this colossal cosmic entity unleashes a power that reverberates throughout the cosmos, leaving us in awe of its incomprehensible strength. Throughout the ages, stars undergo a captivating metamorphosis, transitioning from youthful blues to mature fiery reds. It was in the 2nd century BC that Chinese astronomers made an intriguing discovery, noticing Betelgeuse's distinctive yellow tint that distinguished it in the celestial panorama. As centuries passed, the torch of observation was passed to the meticulous eyes of Greco-Roman astronomer Timai in the mid-2nd century AD. In his detailed records, he depicted Betelgeuse as possessing an orangish or ruddy hue, a trait that continues to captivate our fascination today. This consistent coloring across various civilizations, including medieval observers in the Middle East, adds to the mystique surrounding Betelgeuse. The saga of Betelgeuse takes yet another intriguing turn as we delve deeper into its mysterious antics. Back in 2019, Betelgeuse left scientists scratching their heads when it suddenly dimmed in brightness. The prevailing theory was that a vast cloud of dust, possibly ejected from the star's surface, obstructed our view of it, though the source of this cloud remains shrouded in mystery. Some scientists even entertain the idea that a sizable object like a planet might have disrupted the star's surface or been consumed by it. Fast forward to recent times, and Betelgeuse has stunned observers once more by brightening nearly 50% beyond its usual luminance. Such an unexpected event is a head-scratcher, given that stars typically dim with age. While the exact cause of this luminous surge remains a puzzle, scientists acknowledge that stellar brightness can fluctuate for various reasons.
Take the star Mira, for instance, dubbed the Star of Wonder for its regular cycles of expansion and contraction, which alter its emitted light. Such fluctuations aren't unique to Mira either. Other stars like Algol and around 30 others visible to the naked eye exhibit similar behavior. Deep within Betelgeuse's core, seismic shifts were underway. The expulsion of scorching materials into space birthed a grandiose dust cloud, veiling a significant portion of Betelgeuse's once radiant light. What was once a dazzling beacon in the night sky dimmed to a subdued luminary, its brightness dipping to unimaginable levels. Once among the top 10 brightest stars, Betelgeuse now languished, ranking lower than the 20th brightest. Recent months have witnessed Betelgeuse defying all expectations, bucking the trends of stellar behavior. Scientists and sky watchers worldwide have been spellbound by this mesmerizing cosmic performance. Theories abound, seeking to untangle the mystery behind Betelgeuse's extraordinary antics. Some attribute massive sunspots or dust clouds as potential culprits for its dramatic fluctuations, while others mull over the prospect of synchronized cycles. Their investigations flirt with the remarkable idea that Betelgeuse's supernova explosion may have already occurred. Yes, you heard correctly. While initial estimates suggested Betelgeuse's supernova event was still hundreds of thousands of years away, recent evidence paints a different picture. The last supernova observed in our galaxy, Kepler's supernova, lit up the skies centuries ago. Researchers now propose a model indicating that Betelgeuse is in the late stages of carbon burning, hinting that it might be on the verge of a spectacular explosion. This positions Betelgeuse as a strong candidate for the next anticipated supernova event in our Milky Way galaxy. Like a grand crescendo in the cosmic orchestra, Betelgeuse emerges as a prominent contender for the next stellar supernova within our beloved Milky Way. However, deciphering Betelgeuse's fate is akin to solving a puzzle with conflicting clues. While there are signs of material ejections and subsequent recovery, suggesting a mass ejection event, it's on a smaller scale compared to our Sun's activities.
But here's the twist. Supernovae are real phenomena too. We witnessed one in a satellite galaxy of the Milky Way back in 1987. So, while our predictions regarding Betelgeuse's explosion timing may be uncertain, it's not yet time to plan stargazing vacations around it. The challenge lies in the current difficulty of observing Betelgeuse. Scientists have been scrutinizing Betelgeuse for centuries and have noted its fluctuations in brightness over time, indicating the star is aging and possibly nearing supernova status. However, there's still insufficient evidence to pinpoint exactly when this might occur. A supernova is a remarkably bright explosion that occurs when a star reaches the end of its life cycle. It poses no threat to life on Earth and can be safely observed with the naked eye. The brightness of a supernova is contingent on the size of the star that explodes, and since Betelgeuse is exceptionally large, its supernova would be exceptionally bright. It could shine as brightly as a half moon and might even be visible during daylight hours. Yet, this brightness presents a challenge for astronomers. The intense light from the supernova could obscure other stars and planets, complicating observations of the night sky. One scenario suggests that Betelgeuse might have engulfed a substantial object, like another star, in its past. This event could have accelerated the star's evolution, making a supernova more probable. A recent study has uncovered new insights into Betelgeuse's brightness patterns. It suggests that the longest cycle, spanning 2,200 days, might be the primary driver of Betelgeuse's pulsations. If this theory holds true, the star's brightness could undergo significant changes in the future. However, this remains a hypothesis, and further research is necessary to validate it. Nevertheless, it represents an intriguing development that could deepen our understanding of Betelgeuse and its trajectory. In general, the brightness of a supernova presents a double-edged sword. While it promises a stunning and captivating spectacle to behold, it also poses challenges for astronomers and wildlife alike. Yet, what truly sets Betelgeuse apart as an astronomical marvel isn't just its potential for a supernova, but the unique opportunity it offers.
This colossal star, with its extraordinary size and proximity, affords us the rare privilege of observing its intricate details in exquisite clarity. Unlike distant, shimmering specks of light, Betelgeuse presents itself as a luminous disk through our telescopic lenses. It beckons us to witness its luminous fluctuations, to discern the delicate interplay of its light as it tantalizes us with its concealed mysteries. But the intrigue doesn't end there. The supernova's brilliance won't fade quickly. No, it will linger in our night sky for several years, gradually dimming like a distant star's gentle fade. Yet amidst this fading, there may be moments of resurgence, a sudden burst of renewed radiance before gently bidding adieu to its place in the Orion constellation. While the supernova event poses no direct threat to us, it may disrupt the navigation of certain creatures accustomed to relying on the moon's gentle glow. The influx of additional cosmic light could potentially disorient these animals, causing slight deviations in their nocturnal paths. However, the impact won't be confined to the animal kingdom alone. Both astronomers and stargazers will encounter fresh obstacles in their quest to explore the cosmos. Observing the night sky amidst the illumination of the moon can already be challenging, and the blazing radiance of a supernova will only compound the complexities. Nevertheless, the irresistible allure of this celestial spectacle will undoubtedly capture the attention of countless telescopes and researchers, who will eagerly adapt their observations to capture the splendor of Betelgeuse's climactic finale. The anticipation is palpable as astronomers and enthusiasts eagerly await the grand unveiling of Betelgeuse's supernova. The stage is set, and the universe holds its collective breath in eager anticipation of this remarkable event. But what can we anticipate when this colossal stellar entity unleashes its explosive force? Firstly, let's dispel any concerns. Earth is safely distant from Betelgeuse, ensuring our planet's security. While the supernova will undoubtedly captivate our senses, it will not outshine the moon or the radiant sun. Nevertheless, it will cast its ethereal glow, illuminating our nights and asserting its presence even during daylight hours for an entire year. Envision the breathtaking sight of Betelgeuse's luminous remnants, casting gentle shadows across our world.
Yet, this cosmic extravaganza isn't merely a fleeting spectacle. Rather, it's a performance that will unfold over several years. Initially, the supernova will dazzle us with its brilliance, gradually fading into the depths of the night sky. There may be fleeting moments of resurgence where its luminosity momentarily rekindles, reclaiming its former glory. However, as time marches on, the once familiar star within the Orion constellation will gradually diminish, leaving behind cherished memories of its stellar brilliance. Researchers have discovered that Betelgeuse's brightness patterns resemble those observed in stars nearing the end of their life cycles. This indicates that Betelgeuse may be approaching the supernova phase. Should Betelgeuse indeed undergo a supernova event, it would mark the closest such occurrence to Earth in centuries. The resulting explosion would be visible to the naked eye and exceptionally luminous. However, it's crucial to emphasize that this remains a hypothesis. Further research is essential to confirm Betelgeuse's potential for supernova. Even in the event of Betelgeuse's supernova, Earth is unlikely to face direct danger. Positioned approximately 550 light-years away, the explosion's impact would be less potent than if it were closer. Initially, we would detect a surge of neutrinos, minuscule particles that pose no threat as they don't interact with matter. Following the neutrino burst, a remarkably bright object would appear in the night sky, shining as brightly as the full moon and visible even during daylight hours. This heightened luminosity would persist for several weeks before gradually fading away. Moreover, the explosion would release substantial amounts of dust and gas into space. While this debris might temporarily obstruct light from other stars and induce minor climatic fluctuations, the overall effects would be relatively inconsequential. While this cosmic phenomenon doesn't pose immediate danger, it might perplex certain creatures reliant on moonlight for navigation. Amidst this grand cosmic spectacle, astronomers encounter their own challenges. Observing the night sky is already intricate, particularly under the luminance of the moon. A supernova event of considerable brightness further complicates observations. Yet, the allure of capturing this celestial marvel transcends any obstacles.
Scientists will adjust their telescopes, refine their instruments, and seize every opportunity to witness and document the evolving splendor of Betelgeuse's supernova. Although the James Webb Space Telescope may be unable to directly observe Betelgeuse due to its overwhelming brightness, there's no need to worry. A network of observatories, both terrestrial and celestial, eagerly awaits this significant event. Equipped with a multitude of state-of-the-art instruments and methodologies, they stand ready to unravel the mysteries concealed within the celestial spectacle. Together, they form a global coalition driven by their shared passion for uncovering the universe's secrets. However, amidst this grand cosmic display, Betelgeuse held surprises in reserve. By mid-February 2020, its brightness stabilized, remaining steady for over a span of 10 days. Just when it seemed the dimming event had drawn to a close, Betelgeuse's behavior took yet another unexpected turn. 5 days later, the star abruptly halted its dimming, perplexing astronomers and leaving them captivated by its unpredictable demeanor. It was a curious twist in the cosmic narrative, a plot development that kept us eagerly awaiting answers as scientists embarked on a quest for understanding. A study conducted on February 24, 2020, shed light on the potential causes behind Betelgeuse's enigmatic fading. It was revealed that the star's dimming likely stemmed from the presence of large-grained circumstellar dust obstructing its luminosity. This cosmic dust, akin to a veil, cast shadows upon the star's brilliance, adding to the intrigue of its celestial performance. Utilizing advanced measurements at sub-millimeter wavelengths, the research dismissed the idea of dust absorption significantly affecting the dimming phenomenon. Instead, it proposed that massive star spots might be the primary catalysts behind Betelgeuse's fading. These expansive regions of turbulent activity on the star's surface, reminiscent of solar spots on a grand scale, introduced an enthralling element to the unfolding cosmic narrative. The conjectures simmering within the scientific community edged closer to reality, as the concept of a cold spot on Betelgeuse's photosphere, an elusive anomaly, gained further credence amid a symphony of scientific debate.
The initial hypotheses gained traction and clarity, suggesting that the dust originated from the star's very essence, as its gaseous emissions cooled and coalesced into delicate particles, crafting a transient masterpiece in the celestial realm. Technological advancements have propelled scientists towards profound insights into the universe. From the Hubble Space Telescope aiding in the study of enigmatic cosmic entities, to the James Webb Space Telescope revolutionizing our comprehension of black holes, dark energy, and stellar fates, significant strides have been made. In the year 2022, these advancements pierced through the veil of uncertainty, revealing a remarkable spectacle. An awe-inspiring surface mass ejection akin to a stellar phoenix rising from the abyss. Betelgeuse unleashed a torrent of material, seemingly shedding its luminous skin. This expelled matter, cooling and coalescing over vast distances, gave birth to the transient dust that now shrouded the once resplendent stars from our earthly observatories. The fading of Betelgeuse has finally abated, allowing the star to reclaim its position among the brightest luminaries of the night sky. Its brilliance, shining 100,000 times brighter than our sun, serves as a testament to its stellar magnificence. Yet, despite its dazzling luminosity, Such brilliance comes with a price, a fleeting existence fueled by the rapid consumption of energy. Betelgeuse's inevitable fate looms: the depletion of fuel, a collapse under its immense weight, and a cataclysmic explosion, an awe-inspiring supernova. For a brief period, Betelgeuse will blaze with unparalleled radiance, rivaling the brilliance of a full moon, illuminating both day and night. Its luminosity will enrapture the hearts and minds of observers worldwide. Moreover, as Betelgeuse approaches the end of its lifespan, the prospect of a supernova event looms on the horizon. Although the exact timing of this cosmic spectacle remains a topic of heated discussion, Betelgeuse displays 2 cycles of dimming and brightening, with the second cycle recurring every 5 years and lasting roughly 100 days. Throughout this cycle, the star's outer shell undergoes expansion and contraction, leading to fluctuations in its diameter and average temperature.
Betelgeuse was expelled from its original position within the Orion OB1 association, encompassing the stars in Orion's belt, and is presently observed traversing the interstellar medium at an astonishing speed of 30 km/s. This swift motion generates a bow shock extending over 4 light years. Pinpointing the exact distance to red supergiant stars like Betelgeuse presents a challenge in astronomy. The star's true diameter has proven elusive to determine due to various factors. As a pulsating star, Betelgeuse undergoes fluctuations in diameter over time. Furthermore, its optical emissions change color and diminish as they move outward from the center, complicating the delineation of a distinct edge for the star. These intriguing discoveries shed light on the aging and mass loss processes of red stars, ultimately culminating in their explosive transformation into supernovae. Despite Betelgeuse's peculiar behavior when its nuclear fusion fuel depletes, it doesn't necessarily signify imminent fame. A substantial mass loss event doesn't always serve as a harbinger of an explosion. Experts disclose that a significant surface ejection from a giant star has never been directly observed before, presenting an exciting opportunity for us to witness and study this phenomenon firsthand using the Hubble and Webb telescopes. Betelgeuse's fading has halted, possibly restoring its status as the 10th brightest star in the sky, shining 100,000 times brighter than the Sun despite its considerable distance. Yet, the tremendous energy demands accelerate its eventual demise as it depletes its fuel and collapses, culminating in a dazzling supernova explosion. For several weeks or months, Betelgeuse will illuminate the heavens, rivaling the luminosity of a full moon. While the timing remains uncertain, Earth remains unharmed, as the Betelgeuse supernova will occur over 10 times farther away than the distance needed for a supernova to pose a threat to humans. However, the exact timing of this spectacle remains elusive. It could occur within our lifetime or millions of years from now, and even the most astute astronomers have yet to accurately forecast this moment. Thank you for tuning in to another episode of Voyager. While you're still here, be sure to click on the video on your screen for more captivating content.